Hi there, Z here, and welcome back. And this is the second video in a series of videos that covers how you can use the tools of linear programming to optimize a capital budgeting problem. Um, Now, where we left off in the last video is I was about to show you and walk through a number of examples that get progressively more complex. So we'll start here with in this video, the first two examples, and then we'll get into the third example in a separate video, uh, and you'll see why. So, quick recap. Um, this is a capital budgeting problem, and you have a certain number of projects, but uh, you only have a limited amount of capital. So capex being capital expenditure, and each project has a certain cost and a certain return associated with it. And in this formulation of the problem, it's a once-off kind of a decision where basically this is all the information you're given and you're trying to select which project to do. Now, a naive approach would be a trial and error approach where you would try to change which project you select and see what happens to the benefits, to the overall returns and whether you're still within the required constraint. But linear programming allows you to do that much quicker. And in Excel, how you do that is you open up Solver. And if you don't see the Solver tab, it's probably because you haven't activated it yet. Ignore this thing in the corner. We'll talk about that later. So once you have Solver set up, you like all problems that are linear optimization problems, you start by talking about what you're trying to optimize for, and in what direction. So in this case, we're trying to optimize for the total returns, and we're trying to maximize it, and we do that by varying the cells within this column. And basically, there's a formula that you saw a moment ago that turns this on and off. And there's a certain constraint here where um, all these different cells can only take a value of 1 and 0. So basically, it's an on and off switch. And there's only one other constraint. That's a simple one in that the total of all the capital must be less than the constraint that we've set. And if I hit solve, it takes almost no time and it's cranked out an answer. So that's one way of doing it. And because this example is a bit of a trivial one, you could actually do away with linear programming altogether, because if you were to say example, just take the value over investment ratio, it could be as simple as just looking for the ones that give you the biggest bang for your buck and selecting those projects until you hit a limit. So in this case, we'll take this because it's the biggest bang for your buck, and then followed by these two projects. And you can see we're almost there at the limit. And then we look for the next best one, which could be this one or this one. We'll probably take this one because it's lower in capex, and you end up with the exact same answer. So of course, this only works because it's a trivial example. But I thought I'd just share that in case anyone was going to stop me and say, hey, you don't need to use fancy linear programming for that. So that's that. Now, moving on to a slightly more complicated scenario where it's similar to the one that you saw a moment ago, but now the projects have phase costs. So the over each year in the future, there is a certain phasing of how the cost is spent, and uh, there are limits on a year by year basis for how much money you can afford. And now you're trying to maximize your benefit, but you have to sort of juggle between not just an overall one step or one time period, but you have to look at constraints within multiple time periods. Where if you just blindly use the solution from the previous one and you just stick it in, uh, it's not ideal. You're within the limit, but I'm sure you can do better. So how do we set this up? Because having the capital spaced out actually means you have a bit of flexibility, unlike before, where you're trying to just work on 20, and in a way you were only looking at a single year's worth of projects. Now you're trying to sort of plan for the next 3 years. So the way you do this is you have to add a couple of constraints. So what it looks like is um, you're still trying to maximize for your returns, and now you're changing which project you select, but there are additional constraints. So where in the earlier example there was only one constraint for capital, now you have a constraint where the total of year one must be less than your threshold, or sorry, your ceiling, and for so on for year two and year three. So it's only slightly more complex than the previous one, but hopefully gives you a sense. I mean, if you really wanted to, you could also look at um, NPV, not as a single monolithic number, but over years 1, 2, 3 as well, and then try and do some sort of relationship between cash flow. But I have not done that here, purely because we're trying to just demonstrate the principle. So that's it and done. If I hit solve, uh, and it's thinking a little bit, it cranks the handle, and now you have a much better utilization of the thresholds that we've set, and you get a certain NPV. So that's example 1 and 2. I'm going to try and save example 3 for a separate video because it's a bit more involved. And I'm also going to, in the next video, step away from just doing it on Excel alone and look at other ways that we can approach it using programming language called Python. So till the next video then. Bye.